Okay, so a 60 kilogram student stands in a lift. Calculate the reaction of the lift floor on the student if the lift is accelerating upwards at 2 meters per second. So we're going to start by noting down any of the important information that we have. So the first part is that our mass is 60 kilograms. Now, this is important to note because if you have something else on the lift as well, so maybe the boy is on the lift with a box and the box weighs 10 kilos, then you add that to the boy's mass. The trick here is, are you treating them as two separate connected particles, or are you treating them as one particle? So if it's one, you just add their mass together. If it's separate, you'll have to resolve the forces in both of the diagrams. Okay, so mass is 60 kilograms. If it's accelerating up at 2 meters per second, that means for part A, it's accelerating up at 2 meters per second. And we know that our force diagram will look something like this. So the 60 kilograms is in here. We'll have our weight force going down, WG, and we'll have our normal force going up. Now in part A, we're accelerating up at 2 meters per second, which means acceleration is moving in this direction. So now we can start to piece this all together. Mass times acceleration gives you your force. So in this example, our mass is 60. Our acceleration is up this direction at 2 meters per second. And now when we're resolving our forces, our normal force is going up, so N, and it's being counteracted by our weight force, which is 60G. So now if I start to rearrange this, I'll get N on its own, which is going to give me N equals 120 plus 60 times 9.8. So our normal force that is acting on this is 708 newtons. Now the next one, we're going to look at what happens when it's accelerating down at 2 meters per second. Now we've got two options for this. Choice one is we're going to take the acceleration in the as the positive direction. Now, let's look at what that means. So here was my diagram before. We have our normal force, we have our weight force, and this in here is the 60 kg. Now, in this example, our acceleration was going up, which meant that this was our positive direction as well. Down here, this one, it's going down, which means that's going to be our positive force. So we're just going to start to solve this. Now, you'll see that both of these get the same answer. It's just the textbook jumps between the two different ways, so I'd like you to see both. So, force equals, mass times acceleration equals your force. Our mass hasn't changed. Our acceleration is 2. Now we're taking the acceleration as the positive direction, which means that this one is now the positive one and that is the negative. So 60G minus N. Now I can start to rearrange and solve for this thing. So if I take this N over, it's going to become positive. And if I take this over, it'll become negative. Okay, and that's going to give me an answer of 468 newtons. Now, this is choice 2. You'll see that we're going to get the same answer. Choice 2 is that you take the acceleration as a negative. Which means that we've got minus 2 meters per second as the acceleration because it's in the downwards direction. Now, this is the one that I generally prefer, but, you know, each to their own. So all this means now is our mass is still going to be 60. Our acceleration is negative 2. Now, we're ignoring the direction of A when we're talking about our force diagram. This one's going up, so it's going to be positive. The other one's going down, so it's negative. Now I'm going to rearrange to get n on its own, which means I'm going to have negative 120 plus 60g, which is going to give me the same thing as above, 468 newtons. So it doesn't matter which one you do, just be aware that your textbook can choose to do it in either way. Okay, next question is C. Now, if it's moving with constant velocity, that means the acceleration is 0. So we're going to have 0 is equal to, now when acceleration multiplies by your mass, you have 60 times 0, which just makes 0. So times, now n minus wg, which just means that n is equal to 60 times g, Newton force. Now your textbook will probably leave it in this form because we like to leave things as exacts. And there you go. Done.